Hello. In this video I originally wanted to show a method, a very simple method for etching PCBs at home, for simple PCBs, except I changed my mind. I've been trying to do that, to show that today, except I think it is too slow, so I'm not going to do that again. Instead, I would like to talk about a few ways that you can use to make electronic prototypes and also to make electronic products. And disclaimer follows. This whole video contains my personal opinion. I know some people are enthusiastic about one method or the other, and I have my own preference, and you are entitled to your own opinion. And please search the internet for more information or on whatever you're interested in. This is just a list basically of some advantages and disadvantages and properties of different ways of making electronic prototypes, and hopefully, or maybe they you didn't think of that, so maybe they give you an idea or something that you didn't think of yet, right? So in short, I think there are depending on what you want to do, I think maybe you can divide whatever you want to do into three categories. One is a temporary experiment, yeah, that's column one. So a thing that you want a prototype once to do a measurement on, or to test something, or to test an IC, test a component, or whatever. And after that you can toss it away, right? Then another category would be a permanent one-off. That means obviously something that is permanent, so that you build and build to last, and you're only going to build one, yeah. And the third category I think is an actual product, something that you obviously it's permanent, and obviously it's meant to last, and it should be professional, and it should work always, yeah. So on the left hand, every row is a method of prototyping or making an electronic product, and I'm sure there are more, and I'm sure now once again I have a limited experience with all of these, but I think I used each one long enough to at least have a proper opinion on that, so maybe you're interested in that. Now let's go. First of all, dead bug soldering. I'm not sure if that's a proper term, but it looks like this. Basically soldering in the air. So two components here have two capacitors soldered together, so you can do a measurement, right? So I needed a 2000 microfarad cap, so let's solder two together. And that's how it works. It's very simple. Yeah? Then you have a breadboard. That's something like this. Yeah, so it's a plastic plastic bar with holes in it, and there are metal rails behind the holes that interconnect, so you have areas of holes, rows of holes that interconnect and are separate from other rows of holes, something like that. And you can stick components into it and make connections that way using components and wires. Then stripboard, something like this. I think there's also called ferroboard or ferroboard, I'm not sure how to pronounce it. This is one type, you have a lot of other types. On the one side it's substrate, no copper. On the other side it's copper, and you have lanes going from left to right, that's one type. Or just like this one, lanes containing three, islands, so to say, of three holes, right? Or you have stripboard, that's not really stripboard, but where each individual hole has a small island of copper and is not connected to any other hole. I'll show that later on. Stripboard. Then home-etched PCB. Yeah, I think you all know what that is. You can take a piece of copper, a piece of substrate like this. This is not copper, what you see. This is like glass fiber. With on one side a copper layer, or both sides, but in this case one, and part of the copper is etched away using one of several processes, and you end up with a board containing copper in only areas where you want it. So copper conducts, so you basically trace wires by drawing, either in a CAD program or directly on the board or whatever. Right. Final one is a PCB from an actual PCB house, something like this. Yeah. This one happens to be green, because I think green is a common or cheap solder mask. It's a color of the solder mask. Yeah, you know what this looks like, right? So that's a PCB. Okay, so if you look at each of these methods and judge them by how well they are suited for a type of work, then I think for me that bug program or that bug soldering is very nice for temporary experiments, not nice for permanent one-offs, and not nice for products, obviously, because of several reasons. Breadboard, very nice for temporary experiments, not nice for permanent one-offs, not nice for products. Stripboard is sort of okay for temporary experiments, I think. We will get to that later. I think it's okay for permanent one-offs. I think it's not okay for products, because really, home-etched PCB, I don't think it's suitable for temporary experiment. Actually, the only thing I think it is usable for is for a permanent one-off. And if you make products using home-etched PCBs, I think you're doing something wrong, but whatever you want. That's my personal opinion. PCBs from PCB-house, obviously they're not good for temporary experiments. Obviously they are not good for permanent one-offs. I only made one permanent one-off using PCB from PCB-house. It's this one. That is a configurable load, and using jumpers you can decide how this thing behaves. On the underside there's a fan for cooling, a lot of resistors, a lot of diodes, regulators. I think that's it, to simulate the device. Right. Obviously a PCB from PCB-house is very well suited as a product. Yeah. That bug soldering, that's this. Advantages, it's super fast. Okay, you take a soldering iron and components solder together and you're done. Another advantage is you don't need an infrastructure for this. And what I mean is, you obviously already have a soldering iron and you don't need anything else. This is it. You need a component, a soldering iron. This is as pure as it gets, if you want to call it that. Some people make this into an art, and it looks very pretty. I wouldn't say that is an advantage, but it can look very nice. I mean, it's something that you may not expect when you think about electronic prototypes. Disadvantage obviously is it's fragile, right? This is a shortcut now. Right, next one, breadboard. Now just for this video I made the same circuit 3 times. This is an NE505 LED flasher, and this is a breadboard implementation. So you can see it there. The strips, each column is connected. The holes in one column are connected. The holes in this column is separate from the holes in this column. This bar at the top goes all the way from left to right. It's one long connection, so to say. So yeah, you can stick components where you want them to. The connection is implicitly made if you stick them in the same column, and if you want to make an explicit connection, you use a wire just like this. I use a battery connector to power it. Yeah, this is nice. Yeah. Advantage of this is it's super fast. You take a component, you stick it in the board, and you're done. You can very easily change it. If I want to change this LED, I pull it out, I put a new one in. It doesn't get any faster than that. You can measure very easily. For example, if you want to measure the voltage at a node, you stick a wire in it and you clip a multimeter to it, and also you're done. Very fast. If you want to measure voltage somewhere, or even on the pin of an IC, you stick a scope probe at it. Very easy. Um, yeah, so this is suitable for SMD components. Actually, it's suitable for through-hole components and obviously less for SMD components, except you have these breakout boards. And what they basically do is offer solder pads where you can solder, well, okay, then fine, then solder a chip or solder a SOT23 or solder a resistor or diode or whatever. These have the same pitch as your breadboard. You can stick them in a breadboard and it behaves like a through-hole component. This is really very nice. You can reuse them. Can remove the components very easily with a soldering iron. You have them for small chips. Just test an IC. It's really super handy. I like this very much. It's really, you need these. You also have very small pieces of stripboard, something like that, with again the same pitch as the breadboard, so you can use stripboard soldering techniques and stripboard components on the breadboard. Right. Obviously the disadvantage of a breadboard is that it's very fragile. So I picked it up and the battery clip is loose. So it's not a problem, because at least not what I use it for, because I use it for temporary prototyping. If I have this longer than 1 week on the bench, something is wrong. Okay, I'm not doing what I should do. Okay. Then stripboard. What I use most is this kind of stripboard with islands of 3. Advantage of stripboard is that it's reasonably fast to solder. Actually, depending on the stripboard you use, to minimize the number of wires. Obviously, soldering takes time. Sticking a component in almost doesn't take any time. Stripping a wire, soldering the wire takes time. So what you would like to do is minimize the number of components, but that's limited by your schematic probably, or what's in your head. And also limit the number of wires. Now, it's a nice puzzle to try to limit the number of wires by using the implicit connections provided by the copper islands. So I think that's a nice puzzle you can do. Actually, you can do that while sitting on a couch. I sometimes do that while sitting on a couch when I need to make that. It's nice. Yeah. You can solder simple SMD to this. Obviously, yeah, there is some margin. You can solder 0603, 0805, you can solder SOT23, you can solder ICs if you not too big and not too small pitch, and so on and so on. You can solder simple SMD to this. Obvious downside of this is that it's not reproducible. Every time you want to make a new version of what you already did, you have to do it again. Right. Now you can go a little bit overboard with the stripboard. So this is an old thing I made, maybe 12 years ago or something like that. No idea. 10 years ago. So I think it's a Flash programmer. Now what you see is the same type of stripboard. I like this one. That's what I always get. A lot of wires. These take time. This is not nice to make. If you are making this, it's probably not the best. The stripboard is probably not the best implementation. Right. Then home etching. I tried this. I have some friends who like this very much, who use it much more than I do, or I did. This is a board I found recently containing LEDs. So that's etched. There's even a PCB sitting on top of another PCB. I think from what I can see, the track width is 0.5 millimeter or something like that, and the pitch of components is this one is, I think, 0.65 millimeters. Now this is very nice. I mean, if you for me, when I did this for the first time, it was really brilliant, because you made your own PCB from scratch. You made a drawing, you make a CAD drawing, and you print it out on. I used toner transfer, print it out, and I used what is it, lamination machine to press it onto the PCB, then soak it off, then cover it, then etch it, and blah 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 blah, and then cover it with the conformal coating so it looks nice and it doesn't oxidize. But for me, the second time I did this was a little bit not so nice anymore, and the third time was not nice at all, and the fourth time, no, really I didn't want to do that anymore. This is something that failed. That was a part of a toner transfer. What you do is, actually it doesn't make sense to discuss all the ways to make a home etch PCB, because there's a lot of videos showing that. This is using toner transfer, and that's it. Print it on a sheet of paper, special paper, transfer it to the PCB using heat, then dissolve the paper and cover it with something that doesn't go away when you're etching it, and then etch it. Etching is also, you can do it in a few ways, but I'm not gonna talk about that. Just for this video, what I wanted to do was this: take a very small piece of copper clad PCB like this. On the copper side, draw with a simple permanent marker, magic marker. Actually, for this purpose I got an etch resistant marker for €2 or something like that. I can't see much difference between that and a normal permanent marker, but whatever. So apparently this is the best that there is. What I wanted to do then is not use an etching tank because I don't want to have an infrastructure to etch PCBs. I wanted to have as simple as possible and use as few tools as possible, and occupy the least possible space, and not create waste and fumes and whatever. So what I do to etch, but also with the other PCB, is use a sponge or a kitchen towel, something like that, and rub etchant onto the PCB until the copper dissolves, and that works fairly well. You can get trace widths, I think up to 1/4 of a millimeter or something like that, and then you have to check it using a microscope because it's not very reproducible. This is what I ended up with after etching. I think this is 35 micron copper. Unfortunately, you should have used 17, but just to get an idea. So I use a magic marker to make some patterns on the copper clad board, then etched it off, and this is what you get. This is fairly well, except given the time that it takes, this is not a good method. And obviously if you draw on a PCB, there are limits to the complexity that you can make. What I think is, if you're etching, the only advantage of etching PCBs at home, two advantages, is that it's cheap in the long run. I mean, you need an infrastructure, but once you have that, it's fairly cheap. And if you need a PCB Friday evening after the stores are closed, or Sunday morning or something like that, you can make it yourself, and you can have that on 1 hour later. Yeah? The disadvantages are many. This thing wants to, I think, this home etch PCB, this method, tries to do the same as a PCB from a PCB-house does. But all the advantages of the PCB from the PCB-house, namely, you have mechanical precision. You can make everything appear on the PCB, also holes and the outline and whatever, at a few tenths of microns precision. You cannot do that at home, especially the holes and the milling and so on. Then you have a solder mask that is easy for when you're soldering, obviously, that you don't create solder bridges, and it's also nice that it acts in a way as protection against, for example, if something falls onto the PCB. Well, if it falls onto a component, you can create a shortcut, but if it falls onto a track, you have no problem here, but you have a problem if you have bare copper on your PCB, obviously. And this thing is 2 layers. You can make it 2 layer, 4 layer, 6 layer, 8 layer, 12 layer, 20 layer, whatever. while you are restricted to 2 layers when you do home etching. The vias can be very small, much smaller than you can drill by hand, I think. You have plated vias, which means you can connect one side of the PCB to the other side, and it's done in the process. It is a good connection and it works always. If you try to make 2 vias at home, I think, it's very difficult. You can do it by soldering wires from one side, making a hole, then soldering wires from one side to the other side. That's actually what I did here. Yeah. So, for example, this thing here is a via, so-called via. Comes out of the PCB there, and it goes with a wire to there. Comes out. So that's a bridge, right? A disadvantage of this method is that you will end up designing your layout optimized for home etching. That means everything that's on the non-copper side is a pain, because you have to, that's only meant for wire bridges and through-hole components basically. So what you would probably end up doing is placing all the through-hole components on one side, obviously, because you have to have copper here, because else it's difficult to solder them, and all the copper is on the other side, and there's no copper on the other side, so all the connections you would need here have to be wires. So you will design for home etching, and that does not always end up with the right PCB. For example, ground planes is not easy to do with this. Okay, at least if you use SMD. If you use through-hole components, it's maybe a different story with a ground plane. No. Anyway, PCB from the PCB-house. Through-hole vias, you have silk. You can print some stuff on the silk screen, like a number or drawings or something like that. It's fast if you have a complex PCB. I think there's nothing faster than just drawing the layout and then sending it to the PCB house and getting it back, I think. And complex means multiple layers and many through vias and like small details. It's very durable if you make it, and yeah, downside is obviously it's expensive and it takes time. So if you have no patience, this is not always nice. And basically that was the reason why I started etching in the first place. And there's another PCB, you end up with this, something like that. That's from the PCB-house. If you try to do, at least if I try to do this with a home etch PCB, I have to check it under the microscope, see if everything is correct, fix it. Then, well, there are so many vias I couldn't do that anyway. You can never have vias under the chip because the chip will be lifted, and so on and so on and so on. And if you want to make a second one, it's the same story again. So just for fun, I made this LED flasher, which is actually flashing, but made it on the breadboard. Same one I made on the Stripboard. And actually this is nice because, well, I think it's nice. This is nice puzzle work. There's only one wire, this one. There was a cutoff wire from that resistor there. Little trick. Cut off the, don't know if you can see that, I cut off the legs of the chip that are floating, that I don't need, because then I can reuse that copper under that lead, I mean, for something else. This is how you, at least this is how I connect stuff on the underside, big blob of solder, and that's it. So that's how you can make simple wires. Now obviously this is limited to simple complexity, and if you want to change something, it's not easy. I mean, you have a chance to screw up something. I made, this is the final one. Yeah, I made just now. This is the same circuit. This is etched using magic marker just now, and the kitchen towel with a sponge with etchant. I use ferric chloride just for now, and this took too long to make. I think this was maybe all in all 30 minutes or something like that to make this. the advantage is that you don't need an infrastructure if you etch with a magic marker, obviously, and you etch with a sponge, because you don't need to make, well, yeah, you don't need an etching tank, and also it's pretty fast if you draw on the underside. I mean, that doesn't get much faster than that, except breadboard and except maybe stripboard. So out of these, what I use is this. Sometimes, for example, those two capacitors, to measure something or quickly get something done, or something that I can connect crocodile clip to. Breadboard, I use it a lot, and especially in combination with this. I think not many people use these, and I'm very happy that I found these. These are brilliant. You can do a lot of stuff with these. So you can use SMD, you can test the chip, you can test communication to a chip, you can, if you have a risky sub-circuit of a board that you're making, you can build it on breadboard and do it, and also include SMD chips. Yeah, very simple. Stripboard, yes, I use it sometimes. I recently made a one-off thing. I could justify that by saying that there was the same circuit made 4 times. So basically the puzzle work that you do by placing the components so that you minimize the number of wires was duplicated 4 times. So that comes for free then. But still it took a long, well, pretty long. Home etched, really, I'm never ever gonna do that again, ever. PCB-house, yes. Actually, if you make a product, it should, I think it should look like this and nothing else. And that was all, basically. So that was basically a mental reminder for myself. The next time I am thinking about home etching a PCB, I should look at this video and then simply don't do it. Okay, thank you for watching, and goodbye.